All right, we are continuing quadratics. Today we're looking at transformations, which we have talked about before, but today we're going to focus in on how they affect our quadratic functions. So this is our transformed form for a parabola. A is going to be representative of a vertical stretch or shrink. Also, depending on if A is positive or negative, that will tell us what direction our parabola opens. B is going to indicate a horizontal stretch or shrink. C will indicate a shift left or right, and D will indicate a shift up and down. So as we're going through these, remember vertical stuff affects everything, horizontal stuff affects the X, and what we're focusing on today is that the order matters. The order you apply these transformations matters. So first, let's just refresh our memory on describing these different transformations. So f of x, if we are thinking about our quadratic parent function, let's just go left to right. That negative in front tells us that we are reflecting on the x-axis. That 1/2 tells me that I have a vertical shrink by 1/2. That +2 on the inside tells me that I have a horizontal shift to the left 2. And that -2 on the outside tells me that I have a vertical shift down 2. Okay. Moving on to G, again just going left to right, that 1/3 on the inside there tells me that I have a horizontal change, and because it's less than 1, this means that it's going to be a horizontal stretch by 3, the inverse of whatever factor is being applied there. And then that +5 on the outside tells me that I have a vertical shift up 5. Okay, last one, the 4 on the outside tells me that I have a vertical stretch by a factor of 4. And that negative on the inside with the X tells me that I have a reflection on the y-axis. Okay, let's get into some transformations to our functions now when they are written verbally with words. And again, we're going in order, and the order matters. So for this first one, I'm starting with my parent function x squared, and the first thing I'm going to do is a vertical dilation by 3. So what that means is I'm going to take my function and multiply it by 3 on the outside. Because my function is x squared, this is just going to give me 3x squared. Okay, done with that one. Now I need a reflection over the x-axis. Well, to indicate that, I need a negative on the outside of my function. So this is going to be negative 3x squared. Okay, that's done. Now I need to shift left 5. Well, that's going to be on the inside. I need to go to the left 5, so that's going to be x plus 5 here. So that's going to look like negative x plus 5 squared. Excuse me, negative 3x plus 5 squared. And then the last one, I want to go up 6. So that's just going to be a plus 6 on the outside of my function. And so my final result, g of x, is negative 3x plus 5 squared plus 6. Let's look at this next one. The function I'm starting with is not the quadratic parent function. It's a parabola that is already somewhere else on my graph. So this is the function I'm going to be applying these transformations to. So starting with a horizontal dilation by 1/3. So that is going to look like 3 on the x. Just the x. So for the context of this function I'm starting with, that's going to look like negative 3x plus 3 squared plus 1. So there's my first transformation. Now I want to go up 2. Well, that's just going to look like adding 2 on the outside. But because I already have that 1 there, I have to add 2 to that 1. So I'll get negative 3x plus 3 squared plus 3. And then the last thing is to the right 1. So that's going to look like f of x minus 1. Now keep in mind, x already has the 3 attached to it. So I have to put that in here, x minus 1 plus 3 squared plus 3. So the 3 is actually going to be distributed here, 3x minus 3. And then with the plus 3 that was on the inside, these are going to add to 0. So my final transformed function is going to be negative 3x squared plus 3. Okay. Lastly, sorry about that bell. Okay, so lastly, we've got another function. Again, it's not the parent function, so we are going to apply these transformations here. So starting with a reflection on the y-axis, that looks like f of negative x. So a negative is just going to go on my x, and that one's done. Now I need a vertical dilation by 4. Well, that looks like multiplying your function by 4. So that's going to apply to everything here. So the 4 and the 1/2 are going to give us 2. And the 4 and the 2 are going to give us 8. Then I need to translate this to the right 3. So this is going to look like f of x minus 3. Now, the x already has a negative with it, so it's going to be negative x minus 3 plus 4. So again, distributing there, I'm going to get 2 times negative x plus 3 plus 4 squared plus 8. So negative x plus 7 is what I have in my parentheses. Okay, and then lastly, 8 units up, you're going to take your f of x and add 8. So 2 times negative x plus 7 squared plus 8 plus 8. My final function is going to be 2 negative x plus 7 squared plus 16. All right, let's do a little bit of graphing. This first one, this is just my parent function. So if I need 5 points, I'm going to start at the origin. And then I know I have a point 1, 1 and 2, 4. And I can just use my axis of symmetry to graph the 2 other points, connect the dots. And as pretty as I can make it, there is my parabola. My vertex is at 0, 0. And my axis of symmetry, again, that's the vertical line that goes through your vertex, is at x equals 0. The equation of a vertical line is x equals, my x coordinate here is 0. So let's look at this transformation and see what happens. I am moving 4 to the right here. So there's my vertex, there's 2 more points. 1, 2, 3, 4. I'm going to use my axis of symmetry. There is my parabola. My vertex now is at 4, 0. And so my axis of symmetry has moved to x equals 4. On to 3. I've got 2 transformations happening here. It looks like I'm going to the left 5 and up 6. And then I can graph my other points. Now my vertex is at negative 5, 6, and my axis of symmetry is at x equals negative 5. Okay, now here I'm reflecting over the x-axis, so my parabola is going to open downward. I'm going to the left 2 and up 3, and I'm opening down. So there is my parabola. My vertex is at negative 2, 3, and my axis of symmetry is at x equals negative 2. Last 2. On 5, I have a vertical stretch by 2. I'm going to the right 1 and up 2. And so I'm going to be stretched quite a bit here. I can make sure I get all of my points. My vertex is at 1, 2, and my axis of symmetry is at x equals 1. Okay, last but not least, I have now a horizontal compression by a factor of 1/3, and I'm going down 1. So here is my vertex now, and what's going to happen is my graph is going to get super, super narrow here, and I'm only going to be able to graph 2 other points on this little 10 by 10 grid. I would need it to go up much higher to be able to graph 2 additional points. But my vertex is at 0, negative 1, and my pen is quitting on me, but my axis of symmetry is at x equals 0. And that wraps up our day 1 on quadratic transformations.